Hi, we look at counterfactual generation using reinforcement learning. Counterfactuals for a point x is the closest point in the input in the domain such that its prediction is not equal to the original prediction. What are some advantages of using reinforcement learning for counterfactuals? First, we can generalize across different regions of the input space to find the best policy to find a counterfactual. For example, in this region, the best policy is to go left. Next, certain distance measures in domains such as text and graph are hard to define. We can use reinforcement learning to guide the search process. It's faster to find counterfactuals using RL. If we already have the best policy for point A, we can use that to find the best adversarial policy for point B. Lastly, it does not require access to gradients unlike most methods present today. We now look at tabular data sets. We motivate this using a toy linear example where all the points on the left have a label of 0 and all points on the right have a label of 1. The state space is the x and y coordinate and the action can be left, right, up and down with a unit step of 0.1. The reward for each step is -1, to hit a wall is -10 and to achieve the goal, that is to change prediction, is +100. The optimal policy in this case is to go right for any point starting with a prediction of 0. We look at two algorithms, Sarsa lambda with tile coding and neural net with reinforce. Both were able to obtain convergence with the optimal policy. We now look at a more complex decision boundary in our toy example. Here, the optimal policy is diamond shaped as shown on the right. Sarsa lambda with tile coding was able to converge to the optimal policy. On the other hand, neural net with reinforce converged to a local minima. The policy found by reinforce was all rights or all lefts based on random initialization. We think this is because of lack of exploration that it gets stuck on a local minima. Finally, we looked at a more complex data set of PIMA diabetes with 8 input features. As we can see, as the number of iterations increase, the reward increases as well, meaning that we are able to find a counterfactual in a faster manner.